Hi, Andre from LVGL here. Today I want to talk about this GLYN board we just finished certifying. It's the UI2 kit, which comes like this. You can see it right there. You can see it contains, the version I have here contains the Renesas RZ G2L0 from Caro, which contains the Renesas RZ G2L inside. The Caro product page is also here if you're interested. And we just finished certifying, and as usual we have a detailed guide on how to actually set up the board and the first boot, and how to get your first LVGL application running. And with that's what I'll be doing today in the video. We'll go through this guide and how to make how to run your first LVGL application on the board. There's the guide has a getting started section where you can follow chapters 3, 4, and 5 so that you can set up the display correctly. Here we go. So you can connect the display, and once you have that, you also need to connect an Ethernet cable and 2 micro USB cables, one to port X2 and another one to port X16. X2 is so that we can have a UART connection to the board, and X16 is to how we will actually flash the image onto the board. So before actually getting into it, the guide explains how to set up the Yocto image and how to build it. After you follow all of these steps, you should have both the image ready to flash and the SDK setup that we can use to cross-compile our LVGL application. In order to deploy it, there's also the steps here, and I'll go through them with you. So let me just reset the board here, and first let me connect to it. So if I reset the board and I just press any key, it will stop at U-boot prompt. So I'll just start fastboot USB 0, and now the board is waiting. And now where I finished building the Yocto image, I'll find this tab, deploy images, Renesas RZ G2L0, and Caro image Western folder. This is where I have the image that I need to flash. So I've already installed UU, but if you haven't, you can download it like this. Now I can just run UU-V, and the image is now starting to download. This will take a couple of minutes, so I'll come back when that is done. So I'm back. As you can see, it took just about 5 minutes and 7 seconds to flash the image. Now that I'm here, the image is ready to boot up. But first, let's set up our environment variables correctly, for our display. So the first thing we'll do is set up the video mode environment variable, like this. If I just set it, and then I'll also override the GLYN overlays. This is the overlay list that will actually be loaded when the Linux kernel puts up. Now that I can save my environment, and I can reset my board, and now I can just let it. And now my screen is lighting up, and I can see that I'm getting an IP connection. So it's just connected to my Wi-Fi. Via my Ethernet cable, actually. It connected to my network via my Ethernet cable, and then I connected, and then and I get the IP address here. In case you don't have the IP address, you can always just, if you don't have it, you can just connect to it via the UART cable. You can connect to you can log in via the root user, and then you can run IPA, and it will give you the IP address. This is important for the next step, where we'll actually build our LVGL application and copy it onto the board. Okay, so with the image setup and the board put it up,
we can now actually cross-compile our application and copy it onto the board. So for that, I'll use LV-Port Linux. So if I haven't cloned it, I'll just show you right here. If you haven't cloned it, I'll put the link in the description. If you go down here, you can see the instructions how to clone it and how to set it up. Here I already have it. So what I'm going to do is first just remove the build folder so that we can start from a clean slate. So the first thing that I'll do is source my environment, so my SDK. When after building the SDK, I installed it and I put it in the default path, which is /opt caro wayland, etc. And now I can source the environment variable, the environment file that is inside. With that out of the way, now I can set up my builds for LVGL. So looking at the config file, let's just make sure that I start from 0. So this is the default config file. In this case, I'll go with DRM. I'll use DRM because I know it's a very good driver. I'll disable MIPI-DSI. Unless I can leave it on, but I'll just disable it. Here I'll actually enable Neon because this CPU supports that. And then what else? Can also enable Wayland because I can also use Wayland. And for DRM with EGL, it actually requires to enable the OpenGL driver. So let's enable that as well. And finally, I'll just change the refresh period so that we don't cap LVGL at 30 FPS. With that done, let me just make sure that LVGL okay, I'm at the master branch. So now what I'll make sure is that in my main file, I'll run the demo benchmark. Here you can see that I've already set it up. So it will run the demo benchmark. By default, you'll see this, which means that we will run the widgets demo. You can also run that if you want, but here I will run the benchmark. So with that done, and I have already sourced my environment. If you haven't, make sure you do that. Now I can bootstrap my build process. So I can just cmake-b build. This is just another Slack. You don't have to run it. It's not important. What is important though is that you make sure that it's using the correct C and C++ compiler. As you can see here, when it says check for working C compiler, it will actually use the one that is inside the SDK. This is very important. If you see that it's using your default compiler, make sure that you have sourced the environment before trying to build it. So now that we've bootstrapped the build process, I can just build my application, which will take a little bit more than a minute. So I'll be back for that. So it finished building. It took a little more than 40 seconds, so not quite 1 minute like I said before. Now that it's built, I can find it inside a build bin, and it's called LVGL sim, the target binary. So I can copy it using SCP, specifying the path that I want to copy and the IP address of the board. If I do that, it will copy it, LVGL sim into it, and now that it is inside, I can SSH into the board and I can see it right there. If I try to run now LVGL sim, it won't work. As you can see here, it failed to be. It's warning that it can't become a DRM master. This is because Weston is running, and the Weston is actually the DRM master right now. So in order to stop it, we can stop it via the Weston's init script. So for that, I can just invoke the script with the stop argument, and it will stop. And if you take a look at the screen now, it will be black. And now I can start my LVGL sim application, and you'll see the benchmark running. So another thing that I wanted to point out after we get here, now that I've stopped Weston and I ran the LVGL with the DRM driver, and it works. Performance is very good. What I can now do is run the Wayland version, and in order to do that, I will need to restart Weston, but not just that, and that's why I wanted to do this follow-up. So I can start Weston, and now Weston is running. But if I try to run LVGL sim with the Wayland driver, it will say that it can't connect to the Wayland server. And you can see that there's an error, meaning saying that the XDG runtime there is not set in the environment. So the way to fix that is just to make sure that this is exported and pointing to run user 1000. And now if I take a look at that, this is the XDG runtime directory, and you can see that there's a Wayland 1. This is actually the Wayland socket that the LVGL will try to connect to actually talk with Weston. And by default it should be Wayland 0. Here it's not Wayland 0, but it's okay. We can also export Wayland display and say that it's Wayland 1. And now if I do that and I run my LVGL application, you can see that now it runs and the benchmark is now running using Wayland.